Okay, so section 3.6 is going to review a little bit of what we did yesterday, except we're not going to specifically talk about absolute value. We're just going to talk about transformations in general. We might look at a little bit with lines, which is actually simpler than absolute value. So, the main two types of transformations, and you guys already learned this yesterday, are shifts and stretches. Okay? A shift, or you can also say translation. Okay, that's the word from geometry. It's the same thing. It's when you take a graph and you just slide it left, slide it right, slide it up, or slide it down. You don't stretch it out.
Wait, so the translation is also the shift?
Same, yeah, they're synonyms. Yep. So a shift is when you just take something like on this table and you just slide it somewhere else. I didn't change the shape of it. I didn't stretch the piece of paper out. I just moved it somewhere else. Okay. When you do a reflection, that's on your second line on your guided notes, that's like a flip. Okay? You can also say flip. You can. Bless you. Okay. So flip, reflection, okay, means the same thing. Okay. You guys saw that when we did the V shape. Normally it looks like that. When you flip it, it looks like that. Does everyone have those first two? And again, you guys already saw them yesterday, so it's just kind of like a little bit of review.
Didn't know we're supposed to be writing down.
No, we'll be in the video.
Alright.
So, how to graph transformations. Okay, I'm going to go through step by step what each transformation does. Okay, shift, stretch, flip, just like you guys did in the diagram yesterday, except today I'm going to do it as a table. I don't know if maybe the table it'll be different, so maybe for some people it'll help them better than this diagram that we had right here. But it's basically going to be this again. Okay, just written a little different. Okay, so first thing you want to do to identify transformations is we're going to make a table, but today we're only going to do 3 coordinates. We're not going to do as many. Okay, yesterday we did 5. Okay, today I'm just going to have you do 3 because you guys practiced a lot with 5 already. So we're gonna do less. So that's the first thing you want to write on your guided notes under how to graph transformations. Now, I'm going to show you each transformation. I'm going to show you what it'll look like on paper, what type, how you draw it, and then how you describe it. And a lot of this you guys already know. All right, so here's the first one. So in the first row on your table, where it says problem written like, you're going to write number and then f of x after it.
Wait, do we write this?
Yes.
Oh, okay.
So an example of this would be like 3, like that. That's an example. That's a number in front. That's kind of like this. That's a number in front. Okay? When you have a number in front, we said yesterday, I'm not going to keep going back and forth, but a number in front is a vertical stretch. And that's why I'm having you guys put that right there, vertical stretch. A vertical stretch, how to graph, that's multiplication. Okay, multiplication. How do you know it's multiplication? Because it's a number right next to something. There's no plus sign, there's no minus sign. That's multiplication. And how you would describe it, you guys have that in your notes yesterday too. Vertical stretch by a factor of, and then you say the number. In your notes, you had that right here. Vertical stretch by a factor of number. Okay, so a lot of this is really the same stuff as yesterday.
Jeff said. Thank you.
Okay, the next one is when you have something plus a number at the end. Okay? Like this. A function plus a number at the end. Look what we said yesterday. When you plus a number at the end, that's a vertical shift. Okay? That's what we learned yesterday. Now, if you plus a number, it's going to move it up. What happens if you minus a number?
It'll go down.
Down. I'm going to write them separate. So they're really the same thing, but I'm just going to write one for plus, one for minus. What does it mean if you shift something up? It means that you're adding a number to all the y values. That's how you shift something higher. Right? If you had a coordinate and you wanted to make it higher, you would add a number to the y value.
How do you do that?
Like if I gave you the coordinate 2, 4, and I said to you, I want you to take that coordinate and shift it up 5 spots. The new coordinate would be 2, 9.
Oh.
That would be that coordinate shifted up 5 spots. You just added number to the y value, and the way you describe it, you guys did this in the notes yesterday. Shift up number units. Shift up 5 units. Shift up 2 units. Okay. What do you think that one's going to be?
Negative.
When you minus a number at the end, it's going to shift it down. Exactly. Okay. So when you have a function and you minus a number, it's going to shift it down. What that would do is it would make all your y values lower. So if you had this coordinate, and I said to you, take the coordinate 1, 4 and move it down 2, it would turn into this coordinate. The y value would go down 2. Left and right is the x value. That was going to be the next one we do. But what I'm going to do is I'm doing all the horizontals, all the verticals together. Vertical, vertical, vertical. And then I'm going to do all the horizontals. Horizontal, horizontal, horizontal. And how do you describe when you shift something down? You just say shift down number of units. Shift down 2 units. Shift down 5 units. Okay, so again, I know this is a little bit repetitive, but it's a different way. Maybe it'll click with some people better. Now, a negative in front of something. Okay, putting a negative in front. Go back here for a second. Here's the front, right here. What happened if you put a negative in the front? What does step 5 say?
You need to be flipped over x-axis.
Exactly. If you put a negative in the front, it will cause a vertical reflection, which means it flips over the x-axis. And that's this one. So putting a negative in front, you get a reflection over the x-axis. What does that mean? When you reflect something, it's like everything becomes the opposite. So remember, a negative just makes everything opposite. Right? If you take the number 5 and you throw a negative in front of it, now it's negative 5. That's the opposite. And how would you describe it? Exactly the way I wrote on the other page. Reflect, or you could say flip, over the x-axis. Okay, and those are all the verticals. Vertical, 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 vertical. The next 4 I give you are the horizontals. And maybe if you know them, you might not need to fill out this whole chart. I would probably still fill it out just in case. Or even if you don't fill it out, I'll put it in the video so that way you can copy it. Yep.
Is this going to be like Can we use this as a reference sheet?
Absolutely. Since it's a take-home, you can definitely use this at home. Yep. You can use any worksheet that I've given you this week at home.
Is tonight the take-home quiz?
Yep. And I'll talk about it at the end of class. Okay. So that's our vertical. Now, let's look at what happens if we put a number in front of x. Number in front of x. Go back to your chart. Chart's right here. Number in front of x. Follow the arrows back. Horizontal stretch. That's when you put a number in front of x. All right, so let's go back here. Horizontal stretch. Right? How would you graph it? Well, if you had a horizontal stretch, you would have to, now everything here is going to affect x values. Okay? Everything on the other page was y values. Now we're doing horizontals. Everything is going to affect the x's. So you would divide, yes, Olivia, what do you need?
I gave him the paper because he missed one to copy it, and now he won't answer me.
Okay. Well, it'll be on the video too, so you have internet on your phone that you're using?
Oh, I'm fine.
Okay. So divide x values by 9. Now, don't try to memorize all this, right? If you get a problem on the test, all you want to do is go back and look up how to do it. It's way too much stuff to try to memorize. Especially like how you describe it. Horizontal stretch by 1 over the number. That's the one I did in the homework. I think it was 1 over 1/3. So it's hard to remember all of it. So just use this as your reference sheet. Okay. Adding a number to the x. Go back to your chart. If you add a number right to the x, that's this box. What does this box do? When you add a number to x, that's a horizontal shift. And if you add, which way does it move? If you add, which way does it move? Left. So adding a number shifts it left. And think about a number line. As you go to the left, what happens to numbers on a number line? They get smaller. That's not a mistake. That's why it says subtract there. I know it's kind of weird. You see add here, you see subtract there, but that is how it works. Because if you move to the left, things get smaller. Right? So if you said like you've got the number 2 on a number line, and you wanted to move to the left, the only way I can move to the left is if I subtract a number from it. I have to make it smaller. And the way you describe it is you just say shift left, whatever. Shift left 2 units, or shift left 1 unit. Okay. Here's the shift right. It's almost exactly the same thing, except instead of a plus, what do you have inside? You've got a minus. That's the only difference between these two. Minus, shift, right. And that's exactly the same thing I told you guys here. Negative, right. I just wrote it different. So, on a number line, if you want to move to the right, what happens to numbers on a number line as you move to the right? Yeah, they get bigger. So if you were here and you said to me, move to the right 2 units, 1 to 2, I would have to add to 0. Right? I would have to add to move to the right. So we've got the stretch, shift left, shift right. What's the last thing we can do horizontally?
Reflect.
We can reflect. And that's if you put a negative, let's look at our chart, a negative inside, right? inside. Negative outside, that's a reflection, but it's vertical. Negative inside is the other reflection. Notice how I put the negative inside the parentheses, not outside. So, negative on the inside, that's a horizontal reflection. Same thing we said yesterday. You could also say flip over y-axis. Okay, so as far as notes today, that's a lot. There was a lot of stuff there. That's like 90% of what you have to write down for notes. The last 6 things on the bottom are the 6 things that I keep flipping back to on the other page. They're the exact same things. Okay, so anytime you guys have to describe these transformations, you may not have every single transformation in every single problem. In fact, you won't. I told you that I'm not going to give you a problem that has everything in it at the same time. A lot of them just have one. I think the most complicated one we've done had maybe 4 out of all of them. But you're never going to have them all in the same problem. So, when I ask you guys to describe them, in fact, the 6 numbers that you have on the bottom of your guided notes, those are the order you want to describe them in. It's the exact same order that you guys wrote yesterday. Same exact thing. No difference at all. In fact, I think it's the same slide. I just took off some stuff. Okay, so horizontal shift, horizontal stretch, horizontal reflection. Then vertical stretch, vertical reflection, vertical shift. And again, are you going to have all 6 in the same problem?
No.
No, you're not. And as far as notes, that's the last thing for today. We're just going to do some examples. But I'm going to come back to this when we go through our examples so I can show you guys, when you get one on the test, how do you look it up in your notes, what to do. Okay, does everyone have those 6? So let's try an example. Example 1 has an A and a B. We're just going to look at A for now. I guess we can do B too. Now, both A and B are only doing one thing. One thing. Let's start with A. It's a +3 at the end. So let's go back to our notes. What transformation is a +3 at the end? Look for a plus and a number, and it's at the end. Maya?
Vertical shift.
Nice. Vertical shift up. That's exactly what we're going to do. Up how many?
3.
3. So, describe the transformation. So, I'm going to just write part A, and I think you guys, yeah, you got a little bit of room. I'm just going to do it like this. Part A, part B. Part A is what Maya said. Shift up 3. That's all you have to write. Let's describe the transformation for part B while we're doing it. It's a plus, and it's inside parentheses. So go back and look at your notes. What happens if you do a plus number inside the parentheses? Horizontal shift, which way? Left. Plus inside the parentheses is a shift. So we're going to say shift left. How many? 3, because it's the number 3. Just a coincidence, they're both a 3. So that's it for that part. All right. Now, the coordinate one, we're just going to practice maybe one or two of those because this table thing's not as important, but we'll do it on example one. I'll probably skip it for the rest. All right. We have to pick 3 x values. Pick any x values you want. Let's just keep them simple.
Please excuse this interruption. Thank you.
All right, so give me a nice, easy x number to work with, because I'm going to have to plug it in. So I want something easy. Yep? All right, I like it. 0. Somebody give me another one. Nice and easy. 1. All right, and one more.
2.
Perfect.
3.
Now, let's plug 0 into our formula. What's 2 times 0? What's 0 minus 1? Okay. Now you didn't have to pick 0, but I think 0 is a good one to pick because it's easy. Now let's do 1. What's 2 times 1? 2. Take away 1. 1. All right? Now plug in 2. What's 2 times 2? Take away 1? 3. Okay. Now look at what we did for part A. We shifted up 3. So what I want to do now is I want to take all of these original coordinates, these are just 3 sample originals, and I want to know what would happen if you shifted them up 3. So let's look at the directions for how to do that. When you shift up, it says to add the number to the y. Add the number to the y. Okay, so what's our number that we shifted by? Blake?
3.
We shifted by 3, and we're going to add it to the, what did the chart say?
The new coordinate.
Add it to the y.
The y.
Let me go back. When you shift up, add the number you shifted by to the y. Right. So Maya, what did we shift by?
Then 3. I don't know.
Same question I just asked Blake. We shifted by...
I don't know. I wasn't really paying attention.
All right, guys, you gotta focus. Part A, we shift up 3. 3 is what we shifted by. So if we go back in the notes, it says to add the number to the y values. We shifted 3. So what would be this coordinate if you shifted it up 3? Think of like where this coordinate would end up. James?
0, 2.
Perfect. That's what they were looking for. That you know how to shift the coordinate up 3. Right. How about the coordinate 1, 1? Where would that one go if you shifted it up 3?
4.
Just up. It's not going left and right. It's just going straight up.
1, 4.
1, 4. Yep. And what if you shifted 2, 3? Up 3. Where would that one go?
2, 6.
2, 6. Okay. And now all they wanted us to do is graph this. Right? So now fill those in and see what it looks like. 0, 2, 1, 4, 2, 6. And then just draw a line through all those points. That's it. So I'm not going to focus too much on the coordinate. I'm more concerned if you guys can describe like the shift. Yeah. Yes. All right. Let's try. Okay. Let's go to example 2. I'm not going to focus as much on the table part because that part is not as much on the test. All right, I'm going to just focus on describing the transformations. Okay, so that's your original problem. Here is what they want you to do to it. They stuck a negative in front. They put a negative in front. So, we're going to go back to our chart and look up what happens if you put a negative in front. Okay, so let's go back. All right, let's make it that. What happens if you put a negative in front?
Would that be vertical reflection?
Yep. A negative in the front is a vertical reflection. Reflect over x-axis. They mean the same thing. You can say either one. Okay. So write that in for example 2. Describe the transformation. Vertical reflection. Or you can say what else? You can also say reflect over x-axis. Okay. Again, I'm not as worried about the sketch. I am going to have you guys sketch on the test, but the sketches are going to be the absolute value problems. They're going to be the V-shaped ones. Okay, where you get the 5. You know what I mean? You get the middle, 2 lower than 2 higher. That's what you're going to have to sketch. If you can do this on the test, you're good. Just describe. Right? Let's do this one. You have a number times x, and it's in the parentheses. Number times x in the parentheses. So go back here. What if you have number times x?
Horizontal stretch.
Exactly. It's a horizontal stretch. It's that one right there. So how do you describe it? What does it say to do?
Divide x. Wait, no. Horizontal stretch by factor of number divided by 1.
Exactly. Write this, but fill that number in or use your calculator if you need to. Horizontal stretch by factor of 1 over number. Okay, so let's write that down. Horizontal stretch by factor of, and what was it again? What over number?
1 divided by number.
1 divided by, what's my number in this problem? 1/3. Does anybody remember what I got when I did that on the calculator? I did that earlier.
Oh, you got 1.
1 divided by 1/3.
Wait, why aren't you filling in the? Why didn't you fill in the box?
Because we're just focusing on describe the transformation.
Oh.
That's the most important thing for the test. So what did I get when I did this? 3. Yep. Horizontal stretch by factor of 3. Okay. Let's look at 4. Now 4 is actually, that's kind of what you're going to see on the test. Describe the transformation. Right. Here's the original. The original doesn't really matter that much. The original can be anything you want. This is what's important. I want you to focus on that. Number times f of x. You put a number in front. So go back to your chart. If you put a number in front, which one of those 8 boxes is it? Yep.
Stretch.
Perfect. Vertical stretch. And how to describe it? What do you write?
Multiply y down. Vertical stretch by factor of number.
Perfect. Vertical stretch. Vertical stretch by factor of number. Okay, so Blake, what's my number?
2.
No. What is it, Lucas?
X.
Numbers.
Number. Lucas gave me two numbers. I'm not sure which one. I need a confirmation.
4.
4.
Oh, I think you said note 4. I thought you said note 4.
He just said no blade.
Vertical stretch by factor of 4. This original doesn't matter at all. It could be x plus 2, x plus 6, x. It's just the original if you were going to draw a picture. Since we're not drawing a picture, the original doesn't really matter. What you're looking at is the transformation. What did you do to the original? That's what I care about. I don't care about the original. I just care what you did to it. Okay. Now, this one has a few things going on. How many transformations are in this problem?
4? 3?
3.
Okay.
The 1, the 2, and the 3 are all going to do something. But we have to write them in the right order. What's the order you're supposed to write them in? Right there. So check for each one. Horizontal shift is the first thing you want to look for. Horizontal shift is when you add or subtract inside parentheses. Did we add or subtract inside the parentheses? Yes.
Yeah.
Now what I'm going to do is I'm going to go like this so I can bring those a little closer. Did we add or did we subtract? We added. When you add inside the parentheses, what does it do?
Horizontal shift left.
Yep, horizontal shift left. So you can say shift left. How many?
1.
1. Okay, so that's our horizontal shift. What's the next thing that we look for? Horizontal stretch. If you had a horizontal stretch, Olivia, what does that one look like?
What?
Exactly.
Times
not the same else. Yeah, in fact, I think for I'm going to have you, Olivia, I'm going to have one of you move for the rest of the year.
For the rest of the year?
Tell Jim that.
Which one of us?
We'll do it tomorrow.
Okay.
So horizontal stretch. What does a horizontal stretch look like? Look at our chart. James?
F number X.
So you have a number times x, and where's the number? In where?
4X.
Right in front of the x, right inside the parentheses. Do you have a number in front of the x inside the parentheses? No. There is no number next to x inside the parentheses, so that means you do not have a horizontal stretch.
Or reflection.
Or reflection, because 2 and 3 are the same box. We talked about that yesterday. In order to have a horizontal reflection, you would have to have a negative in front of the x. We just said there's nothing in front of the x. There's no number, there's no negative. So the next thing is vertical stretch. What does a vertical stretch look like?
Number in front of the volume.
Yeah, number in front of everything. Do we have a number in front of everything here?
Yes.
Yes, we do. So we're going to write vertical stretch. What comes next? Vertical stretch.
Vertical reflection? No.
Under written like on your chart, or how to describe it.
Vertical stretch by a factor of a number.
Perfect. Vertical stretch
1 million.
by a factor of how much?
2.
2. Okay, next thing is a vertical reflection. For a vertical reflection, you'd have to have a negative in front. Is there a negative in front of the 2?
No.
No, there's no vertical reflection. Vertical shift. Vertical shift That's when you have plus or minus a number at the end. Do we have plus or minus a number at the end?
Yeah.
Is it plus or minus? Plus, so it shifts which way? Perfect. Shift up 3. So again, you don't have to memorize all that. Just use your chart. All right. So, homework is the take-home
At
test.
this time, any juniors who are not in attendance,
Okay, you have the option, if you don't want to do it as a take-home, you don't have to. I'll explain it in a second. It is due at 8:30 tomorrow,
Is that when this class?
because that's when we have class tomorrow, second period.
Wait, so
I was like,
how
wait,
come
Okay, guys, I gotta get through it. If you have questions, you can ask me after. It's due tomorrow at 8:30. It has to be given directly to me. Not under door or given to anybody else. Don't say, oh, I put it under your door before you got here, so I don't know, it's gone. You have to give it directly to me. If absent, what you can do is email or, yeah, actually email, that's pretty much it. If you're absent, email by deadline, okay? If it's not turned in by 8:30, if not in by deadline, it's a 0. Now, your other option is if you say, you know what, I'm going on vacation, I don't know if I'm gonna have internet, I'm not sure if I can get it to you by 8:30, that's fine. You can do it a different day. I will still give it to you as a take-home. You could do it next week. If you came on Tuesday to pick it up, I'd say, okay, it's due Wednesday. If you picked it up on Thursday, I would say it's due Friday. You can have one day to do it as a take-home, just like everybody else has the one day, okay? If you said, you know what, I just want to take it in class, that's fine too. I'll give you time to do it in class. So if you take the test, you have to get it to me by 8:30 tomorrow, or it's a 0, whether you're here or not here. If you don't think you can do it by 8:30 tomorrow, don't take it. I'll give it to you a different day, okay? But that's only if you're not here. If you are here right now, I'm assuming everybody's gonna take it, unless you know you're not gonna be here and you have no internet, no way to get it to me tomorrow. Any questions on that? Yeah?
8:30 is like the start of class.
8:30 is the start of class. So if it's 8:31, that's fine. It's like when the bell rings.
Alright.
Yeah. Yeah.